Okay, so last lecture we are discussing about compression effect of the member. So I am revising. So for checking that, this is your shortcut for modeling in general, and in which you can find the specification. This is exactly same procedure that we gone through command, member specification and compression member. It will open same window at right side. Okay, this is your right side pane, open same window. This is easy to operate through this page control tab. So this is general, specification and member compression. Okay. So at presently, what is that what we are discussing, I am making that inactivate. The effect of this is inactivate. So that is by through that command prompt I am going to STAAD editor. So this is your icon for STAAD editor, or go to edit input file, command file, and in which you will find member specification, member compression 1 and 2, these two line. I am highlighting these two line. દેખાય છે ને બરાબર? This is your member 1 and 2, that is compression. So now this line I make ineffective in this command file by clicking this line. So this is icon over here, that first is star and then line is written. So and as soon as I click this become inactivate. Now I am closing and then saving, and again running. Now you will find there is no compression member over here. So obviously in post processing, when we look at to axial diagram, you'll find this is your red color. Previously we are not there. Okay, so what is the red color? So to look into structure diagram, load and result, this is your green for compression and red for tension. Now this is your tension and this is your compression. So by giving that compression member, we can make only use of this member when compression fact force acted upon in this member. Now similarly this is your tension. If I want to make ineffective, so in same procedure, command, member specification, tension only. So I am just adding and assigning by selecting, use cursor to assign. I am assigning this. Again running. This is I am closing and running the analysis engine and checking what is the effect of that. To warning. So let's say there is no green color.
These commands, compression only and tension only, are useful especially for bracing. Sometimes bracings are able to take only compressive load. So in that case, we can define that member as a tension only, right? Sorry, compression only. Sometimes wires are there, so it will not be able to take compression. And for that kind of members, we can give tension only command. Right. So that way, for bracings or some members which can only take compression or tension, for those members we can define tension only or compression only. So it will be analyzed accordingly and it will be designed.
Okay, now let's add the bracing and look at that inactivate command. So by adding the now member, as you have to add the beam. So I want to add the beam in cross manner like this, connecting the node 2 and 4 and node 1 and 3. I am adding the beam. So for now adding the beam, again go to geometry, add beam. Add beam, there are so many options. Add beam from point to point, add beam between midpoint, and this will discuss in frame structure. Okay, so let's take beam, add beam from point to point. So we have a definite point, that is one is second point, another is 4. Now other is 1 and 3. Now I am skipping this and again running the analysis engine. Why, what is that error about? Probably
Member property.
member material specification. So again for checking that elastic modulus for 4 and 5 and section property for 4 and 5 is missing. So simply close this, go to general, property, and assign same property because this is your dummy. Okay. Assign to view. Now I am running now. Now there is no error, no warning. Now in post processing mode, I am closing and checking the diagram. This is deflection diagram. When you move to post processing, it will always open. So I am simply making of this diagram and looking that axial force diagram. So this green color is of compression. This red, all three member as in tension. Now like that, this specification, other specification you can completely make inactive member. So that is same procedure, go to command, that is your member specification and inactive. So just I am adding this into library. Now I am selecting this member and assigning by using the cursor. Now again running the engine. Let's see.
So the other member became heavier. If
Okay.
you make one of the members inactive, naturally the load will be transferred to the other members, right? So
Okay, so the intensity is get changed. So for checking that you have a view value in axial force diagram, you can check that, and then by trial error, this advantage of this tool is like that. You
and
require the
the two members, vertical and horizontal, were in tension. You know that? Now it is in compression. અથવા તો reverse થઈ compression માં હતું tension માં હતું inactive condition. So that things get changed once you give tension only, compression only, or inactive member. The load distribution will be different.
so by a trial and error, you have to compare that maximum force axially taken by the member, and then you have to decide which you want to keep or which you don't want to keep, on which is if you don't use of it or make it inactive, then what is that effect of the structure? It's really nothing that affecting the structure. Then it's really nice to remove that member. Okay, if it is ineffective totally by inactivating that member, then you can realize it is better we don't keep that is. Okay, so like that you have to make the trial and error. Okay, this is all about that portal frame. Now that is our 3D space frame. Okay, before that, okay, in 3D space we'll discuss. So I am keeping this file as a portal frame. Now I am creating new file as a space frame.
Up till now we were clicking on plane. Now it will be space.
Now in space. So I am giving that 3D frame. Adding beam, and then finishing. Okay, so now this is your in front view. The grid you can see that only because of okay, let's close this grid. I will later on show you. The first node is now I am adding the node in plan. So this is plan is over here. What is the plan? This global axis, the coordinate which has a z and x component and y is a 0, that all are in a plan. So I am carefully giving some of the node in x and z. So second is 3 0 0, next is 0 0 3, next is 3 0 0. Okay, now I am clicking on this and going in top view or bottom view, a top view or bottom view. This is in plan. Now I am connecting this node. This is 0 0 0 0 0 is this one. For visualizing the node, I am clicking this node. This is 0 0 0. Now axis, look at that axis orientation. This is towards the positive x, this is towards the positive z, and y is coming orthogonally out. So this is 0 0, this is next is x3 z0, this is z3 x and y0, and this is x and z3 y0. Now I am connecting this member same by geometry, add beam from point to point. Okay, I am clicking, this is 1, this command still is continue. Now next command is geometry. In geometry, so add beam between midpoint. Okay, between midpoint of what? So definitely of beam. So I am clicking this beam. It is automatically detect the midpoint. Okay, I am going on this direction, automatically detect midpoint. Again I am going geometry, air beam between mid to mid. नहीं था. Geometry, air beam between midpoints. So I am clicking this. I have clicked this node, they have considered this mid of this beam. So it is better make a escape will deactivate that your first action. Now I am going to again now I am clicking on this beam. Okay, so it is considering the mid of these two members. Now like this. Now next option is what is that? Let's look at geometry, add beam by perpendicular intersection. So I am clicking on this beam and now I am clicking on this beam. This probably consider at midpoint. Let me delete this. Now for undoing that action over here, the record of your action is recorded over here. Okay, so I am selecting some of that last and then I am giving that enter. Selecting or in keyboard one by one press, there's just like a window, that is Control Z option is available. You can undo, that is your action. Control Z, just a window option. Okay, now I am going to that third option, add beam by perpendicular intersection. I am clicking this beam. Please select a node first. Okay, so let's add one node over here, that is your in between. This is x is a 4.5 and z is 1.5. Now I am selecting this node and now I am clicking over here. So this will make from one node to that other location of the beam where this beam make as an angle perpendicular. Understand? So this will generate the beam from one node to at other beam, where this beam make angle 90 degree. To better understand, let's make that other. I am clicking geometry, add beam between by perpendicular intersection. I am selecting this. I am clicking over here. The intersection point is outside the beam, cannot be create a beam. Please select another beam. So what does this mean? The probably from this node the perpendicular intersection is over here. Then this beam is generated and it will make the 90 degree to that. But this is point is outside the beam. Are you understanding or not? Let's look at that warning. What is the intersection point is outside the beam, cannot create a beam. Please select another beam. So this is not possible. You will find same warning over here, but if you do at opposite to this, now by doing that we have make that one beam, but you know that everybody the beam get overlap, and that is in design criteria and analysis it create the problem. So now one tool is there. Write down the tool. In tool, what is that? This is your check of overlapping collinear member. So as soon as you click, it will show that which is collinear member get overlap. So that is 6 and add. So highlight both. Highlight first beam. So this is your 6. Highlight second beam, and this is whole as a 8. So now this is just for checking. Okay, so one by one, if you want to delete then the overlap member, again go to tool, click on check overlapping collinear member, click on highlight first and then close, and then simply press delete of your keyboard. So this is get removed.
It means that one member which was overlapping between that node and that node has been removed.
Now I am again this removing this thing. Okay, I am deleted everything. Now I am again going to geometry, then again on that grid. This grid is on. You are not.
Another method for creating a geometry, snap node grid. So through grid directly you can make the geometry of a structure.
Okay. So this is create. So this is, I want to create in XZ plane. Okay, so by default each and every time if you open, it will show on elevation, always in XYZ. When you open the grid, again I am clicking geometry, snap grid node, I am clicking on beam. Okay, so always open in XY, that is always in elevation. Okay, now I am dragging upward and going to create. So in create, there are different options: linear, radial and irregular. Okay, so it's better for snapping the grid you have a linear. Okay, I am making it a XZ, giving that name grid 1. I have make that plane XZ plane. Okay, the grid original is X, Y, Z 0 0. And left, what is that? This is your construction line. Construction line, what does that mean? From the left there is a 0 0, and along the right side, this is extension of 10 line, construction line, which is space 1 meter, just like this, along the right side. So if you want to left side, so this 0 in other side you will also find some of the grid. So let's keep it, this is also 5 and this is 5. Now this is Z in 5 and this is also 5 and space at a 1 meter. Now I am giving that OK. Now I am clicking this grid. Okay, so this is by default in XY plane, so I have to go into plan. So this is to view this one. So now it is in plan. So my 0 0 is at center in this 5 in X direction. This is on this side. This is 5 construction line, and other side this is 5 construction line at a space of 1 meter. Okay, and similarly along the Z plane towards the Z positive there are 5 construction line, and at above that there is also 5 construction line. If you want to edit that, you can do this grid, remove this is confusing, so make it this is 0 and this side as a 10. This is 0 and this side as a 10, and create as a OK. Now I am creating any plan from starting 0 0 0. So 0 0 is always at a top left corner. Remember this, 0 always in plan you will start with the top left corner. So I am start snapping the node by clicking at this over here, snap node and beam tab. I am clicking on this. So now I am starting, the beam is like that, 0 to 4 meter, then at 0 to 4 to downward 3 meter, other this is again 3 meter, like that. This is one geometry in plan. I am randomly constructing. I am pressing escape. Now I am making that another snap node. I am again clicking snap node beam for making the continuation. I am extending like this. Now this is again I am clicking escape. Now again I am starting from any node from over here to like that. Now I am clicking escape, then I am closing this grid. You'll find in plan something like this. Now this is in one direction. I'm unable to select this is only because of my cursor is a beam cursor. This is in plan. This plan is a typical along that elevation. This is typical along that elevation. I want to extend this plan and generating 3D frame. So write down very important command for repeatedly copy along that all three direction. That is geometry translational repeat. So click on this translational repeat. Click on that, it will open another window. Okay, so in window what you will find, this is your some graphics is provided. Over here the global axis is shown. This is your start node and this is step 1 and step 2. So something step like that is written over here. Now this is your global direction x, y, z. Over here number of the step increment and decrement, at least one is required. Once you have moved this, use this command, at least one copy is required. So I am making that another increasing 2. So over here one step is increased. The default step spacing is 3, that's why over here above that written 5, 5. So now I have changed default step spacing is 3. Okay. Now this is global axis. What does this mean? This is get repeated along this plane x, y, z. Now since this is your plan, this is get repeated, this is your plan, this is get repeated along which direction? Y. So I have to move to that global direction y. I want to make that step 2 instead of let's increase as a 3. So default step is 3. Now I want to change that second step spacing as a 3.2. Next is also 3.2. Now over here the renumber bay is there. So in general for let's make what is the renumber. So renumber of the bay, the node and beam that is copied or generated by this command is numbered again. So from that what is the starting number? So this is your starting points. The step first, let's give it start from 100. I will show you what is that effect of that. Next is 200. So it will indicate which level is there. Third is 300. Now next checkbox is link base, links tab. So this just copy the floor. But in between, do you like to have a link? Means you like to have a add the column? Yes. So as soon as you click this, this open will base will activate. No, okay. There is no. પૂછશે હવે પાછું. Now I want to link this tab. Now I am pressing OK. So what is that? Please select member node and plate or solid for the translational repeat operation. Okay. So this is prerequisite for selection. I am selecting all geometry. I am simply clicking over here by.
So actually for translation repeat, what are the geometry or what are the members to be translated? That has to be selected first and then go to translation repeat. Right. Vishal has not selected the geometry and that is why it has given that no member.
So what I mean to say that if you have got forgotten, then it will give you that warning, please select the geometry. So I am selecting and now pressing OK. So now this always you will find the warning. This is an irreversible operation. All undo and redo record will be lost. So all save view based on this previous numbering will become invalid. Do you want to proceed? Yes. Now you are observing that colors has been become darkened. Still you are in plan, you cannot see the other dimension. Let's make isometric view. Now it is created 3D space frame. Now in general, this at the bottom the geometry is still selected. At this level you don't like to have a beam, I am simply pressing the delete command. All selected beam at the down level get removed. Now I am going to at front view. Now at this level, what is that node and beam I want to look into? Okay, what is that beam and node number? So now not down. For checking that, or in this window you can find that the beam number is 305, 306, 307, like that you are finding. But properly checking that, now one way to select any geometry is by cross window. This is by cross window. I am making that cross rectangular at this level. So at this level all beam get selected. Understand? If I want that top level, so I am clicking over here, then pressing left key of my mouse, then stretching this window like this. This is one way of selection by stretch window. What is that? Selection. First click anywhere, then press left key of mouse, then scroll your mouse along that geometry. It will generate that cross window. Now select this. Now what is get selected, you are unable to see in front view, make isometric. This is your selected. Now at least this level, what is that beam number I want to look into. So after selecting, go to view, then new view, so for new view it asks that do you like to have this display in same window? So this is your window, frame 3D STD wall structure, or you have a different window. So I like to have a different window, create a new window for a new view. So I am pressing create a new window for the view. I am pressing OK. Now this is in elevation. So let's make in isometric. Click on this window and then simply press what is the keyboard shortcut for knowing that beam number? Shift B. And for node, so this is your only that modification done only for beam. The node number has no modification at all. Okay, so in third copying I have given the start number of beam is 300, then later on 301, then 302, 303, 305. Let's have in top view. Now at this level you can save this view also. And save view we can open also. Now for saving this view, go to again view, view management, save view. So what name you like to have? Or third level, okay. So this is you will find third level floor. Now I am closing that. This is already saved. Now again you want to see that view. Now open view is available. Open view, this view, okay. You can find this view. Now let's check it quickly. I am checking that beam number over here, selecting, and this is another approach. Just right click of the mouse, select this by stretch window. Other option is just right click of mouse. You will find new view. It will open same location, create a new view. Okay, so I want to create a new view with new window. Go to an isometric view and press simply beam number. So this beam at level second started 200. If you don't want to save, then simply click, and if you want to save, then again this is your same procedure. Let's have a save. Select, right click, new view, create a window for view. दिखा दो नहीं पाते हाँ तो આપણે break પાડી દે. So we have a 10-minute break, okay, and we'll continue then after. Now for saving this second level view, I am making isometric view and then pressing shift N for node and shift B for beam, and then going to view management and save this view. This is your second level floor. I'm down pressing OK. Again closing this. By stretching window, I am selecting this level, right clicking of the mouse, then I find the new view option. Create a new window for that view. I am going to isometric view, then I am pressing shift N and shift B. So it will create a view. So that I am saving. Okay, now this is your frame structure. Now just like a portal frame, I have to assign the support. So quickly I am assigning support geometry, and this is your general, and that this is your support. First I am giving the support instead of property. This is your support. So I am adding that at ground level this everything beam is fixed. So I am creating a fixed support, just adding. I am selecting now, then going to front view carefully. Front view. Now my cursor is changed as a node cursor, because this thing you can only assign to that node. So I am selecting at this level by stretching window the node. At front view I have selected, and I am checking in by clicking isometric view whether everything is selected or not. Probably selected. Now by selecting, after selecting you will find assign to selected nodes activated. Just assign. Okay. Now quickly to property. This is a property window. Okay, this is a property window. In property window I am going to that define. This is your same way through command, then member property prismatic. So it will open like that, or through page control tab. This is your general, then property in which define. It will open this. So let's have a sum of rectangular of a section of some of that column I want to assign, that is rectangular beam. So YD is 450 and this is your point 300 ZD. I am adding other section is by of a square, that is 4545. I am now adding. Now again that is another is 0.6, 0.45 I am adding. Okay. Now I am adding. I am selecting the circular section of a diameter of 300. Just adding. This is I am closing. Now this is I want to assign at a first level beam. So how will I select particularly at this level each of the beam? So this is one approach. Go to front view. Just select by stretching window this beam and check whether it is selected, whether all are selected. Probably all beam are selected.
Or you can open the view which we have already.
Or other way, the best way is open the view that is at particular level, first level. Okay, and then this is your selected. Now assign to view. This is assigned to all B at a level first. Again, this is closed. That's why we have saved this view. Now, the second property is I like to assign at second level beam. So go to view, open view, and that is second level. And now this is selected. Simply select assign to view and then assign. This is assigned to that second level. Now at third level, this again go to view, open view, and simply assign. Assign to view, assign. Now column. Okay. So for another way of selecting, if for each of the beam or column, that is one thing is available by select menu. So what is that option? Go to selection approach. This is by selecting or assigning, by saving or making the view. Another is by selecting. So go to select. There are lot of option is available. So first that this is your cursor. Yesterday I have taught about some of the cursor node and beam. Other will in next lecture I will make. Over here in this panel, so beam parallel to X. This is your about global X. So as soon as I click over here, you will find this is beam parallel to X. So if your geometry is you want to assign something like that, so select beam parallel to X. So everything parallel to X in this geometry is get selected. Again beam parallel to select beam parallel to Z. So this is assigned geometry. Now probably I want to assign the all column as a circular point 300. So I am selecting beam parallel to Y. Now this is selected. I am selecting assign to selected beam, assign. Now by some procedure like that, if you have skip anything, so in select one check is available. Select by missing attribute. Missing attribute. So what is the missing property? No entity with missing property is found. In select menu, select by missing attribute. Elasticity, probably no entity. Poisson's ratio density, no. Or this select is also available for by list of beam or node numbers, or particularly let's say I want to assign particularly anything. This is to beam number 304 as a as a 0.45 by 45 beam. So this I am going to menu as a select, then by list of beam I am entering over here. There is two way of option is available. It will list all the beam number. You can scroll and select particular beam, or other way is if you know the specifically beam number, you can enter the list, that is 304. Over here select the listed entity. I am clicking this thing. This is visualizing over here. I am selecting another by giving the space in multiple format. So give the space and write down second entity. So this is 3 is selected by giving the space select list, and I am closing that. Now this is selected and this is also selected. Now this is activated assigned to selected beam. So this is similarly by list. You can node select the node also. And now so by inverse, what is that inverse property? Now I am selecting beam parallel to x. Now selecting beam parallel to z. So this is at plan level, all typical floor level that beam in xz plane is selected. Now I want to select, this is in available selected quantity in this window. Now I want to select the column and parallel to y plane. So this one option is beam parallel to y, you can directly select, or you only want the beam which is parallel to y. So inverse beam selection. So if you click inverse beam selection, that means that whatever selected geometry over here, other than that geometry, it's so. Whatever the available selected geometry in this window is there, other than it will show. So selected geometry was xz plane and y is nothing but that. So by inverse selection approach, you can select the beam. So that is available for node and also for geometry of any other kind. Now in select menu, what is that? Okay, so by all approach is all there. If you since this is your dummy quantity, you can press all beam also. That will seal all everything beam in your geometry. Then next is all node. So node, it will select the node, all node, like that. In select by all, by inverse, by list, by specification. By specification means let's have a property name. So property name of which? So those who have assigned property as a circular 303. As soon as I go clicking that, it will show this member has assigned as 0.3 diameter circular concrete property. So I am closing that. It is now selected. Like that, by by specification property name, that is 450 by 450. So this beam at the second level is assigned 450 by 450. This is not assigned, we have changed. We have changed. We have changed, but that property is same. 0.45 by 45. Look at that. I have added mistakenly two property. That is reference 1 0.45 multiplied by 0.5, and third, that is rectangular section 0.45 0.45. So reference 3 and reference 2 are one or same, but it is different thing. So it will select by approach like that, by specification. Okay. 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 So I am some of the tool. Okay. Now what is the multiple structure? Now I am giving that some load. This is your property is assigned. The next step is loading. Okay. So now for that load, I am generating the load case detail, adding the primary load. So this is one approach. Okay. This is your other approach. I am clicking the load case detail through page control tab. How? Let's see. Here I am in setup, and now I am moving into general. This is page control tab. Check it my cursor. I am clicking general, then load and definition, and now I am load case detail selecting and then pressing add. So this is different window, different way to reach over here. The other way, last time I have shown you command loading primary load. Okay, I am simply selecting load case detail. Now I am adding. Okay, so let's have some of the dead load, that is DL, next is a live load, and dead load. I am in this particular primary load, I am selecting dead load. I am adding first, that is your self weight. So in y direction, that is gets y direction factor -1, means that this is downward, vertically downward. I am simply adding that.
It
So
will
this
automatically calculate the self weight of each and every member, and the factor is 1, meaning whatever is the size and property given, accordingly it will calculate the self weight.
So in previous version, this is your auto assigned load. Means that if you add in previous version before to 2008, if you simply add the self weight, it will automatically assign. Now in this self weight of the watt, so whichever thing you select and assign, that only we consider in self weight. Otherwise in previous version it will automatically consider everything which is available in geometry, consider as a self weight of that geometry in a dead load case. Now this is unassigned is available. So this is I have added. Now I am closing. This is question mark, shows that it is not assigned to anything. So I want to assign to whole geometry. So in case of if you want to that assign the geometry about this level only, only this much geometry. Select this and assign to selected, simply assign.
What does it mean? We have neglected self weight of bottom columns.
Bottom column I have ignored. So now if you click on that, you will not find anything, just like a other load case. So it is which beam it is assigned, you will unable to find. But as soon as you click, you will find some of the list over here. So list, we have generated geometry and we know that the beam number 100 to 120, at which level it is located. By that we can, okay, you know that 100 to 128, that is at this level. 200 and 228 at this level. 300 and 315 at this level. You are finding the list but no color over here on this screen. So please remember that. Now I am adding the dead load of something as a member load on beam of a wall that has a full height with a density of 19 kilonewton per meter cube. How to calculate? Okay. So density of the wall અમારે લેક્ચરમાં જવાનું છે. ઓકે, સો વિલ કન્ટિન્યુ આફ્ટર 1 hour. મારે પણ લેક્ચર છે, હું લઈને આવું. બરાબર, સ્ટોપ કરી દઉં છું. બરાબર, હેલો, નેક્સ્ટ સેશનનું ફરી. ઓ માય ગોડ.